Here is a sentence I said for years without ever really thinking about it. Nothing travels faster than the speed of light, and it sounds like a fact about light. Light is the fastest thing there is. Everything else is stuck behind it. End of story. That is how I was taught it. That is how I repeated it. And it is wrong. Not a technicality wrong. Wrong at the root, because on the 17th of August, 2017, we caught something that should not have been possible. Two dead stars, 130 million light-years from here, spiraled into each other and collided. That collision sent out two completely different messengers. A ripple in space itself, gravity, which has nothing to do with light, and a flash of gamma rays, which is light. They raced each other for 130 million years, and they arrived here 1.7 seconds apart. Sit with that for a second. Gravity is not made of photons. It does not care about electric fields, or magnets, or anything Maxwell ever wrote down. And it travels at the same speed as light to about 1 part in 1,000 trillion. In human terms, that is like running a marathon against someone and finishing so close that the gap between you is narrower than a single atom. That is a clue. The universe has a speed, and light is simply one of the things that happens to hit it. So if that number is not about light, what is it about? What is actually being measured? The answer turned out to be stranger than the version I was taught, and a lot more useful. That number is an exchange rate. It converts space into time. And once you can see it that way, the things that sound insane about relativity, time slowing down, the twins E equals mc squared, stop being a list of weird facts and turn into one shape. There is also a sentence a lot of people repeat about this, which is that you are moving at the speed of light right now, sitting still, doing nothing. I want to show you exactly what that sentence means. And I also want to be honest with you about where it stops being true, because almost nobody does that second part. Let us take the name apart. So where did this number come from in the first place? That is the first clue that we named it after the wrong thing. If you saw the last video, you know the story. Maxwell was not hunting for light. He was fixing a broken equation about capacitors. He wrote down the 4 laws of electricity and magnetism, patched the hole in the 4th one, and out of the repaired set came a wave. When he asked how fast that wave travels, the answer was 1, divided by the square root of 2 numbers. And here is what I keep coming back to. Those 2 numbers have nothing to do with light. One of them you get by rubbing charges together and watching how hard they shove each other. The other you get with wires and magnets, batteries and coils on a wooden bench. There is no lamp anywhere in that experiment, no sunlight, nothing glowing. Multiply them, take the square root, and out falls 300,000 kilometers per second. Now, the reason that landed like a bomb in 1865 is that people already knew that number. It was the measured speed of light. So Maxwell concluded, correctly, that light is an electromagnetic wave. Enormous discovery, completely deserved, but look closely at what happened. A number describing how empty space responds to electricity, and a number describing how empty space responds to magnetism, combined into a speed. Those are properties of the vacuum, of nothing at all. They describe the room, not the furniture. We measured the speed of the room, and we named it after the first thing we saw running at it. Okay, now the part that used to genuinely irritate me, and when I went looking, I found the same complaint written out by hundreds of other people trying to learn this. Every explanation of relativity eventually arrives at the same sentence. The speed of light is the same for every observer, no matter how fast they are moving. And then it says, this is a postulate, an assumption. Einstein assumed it, the maths works, the experiments agree, moving on, all of which is true, and none of which explains anything. It is a receipt, not a reason. Because the claim being made there is genuinely absurd, and I want to make it as absurd as it actually is. Say you are on a spaceship, traveling at half the speed of light, and you switch on a torch, pointing forwards. Common sense says the light leaves you at c. You are already doing 0.5 c, so someone watching from outside should clock that light at 1.5 c. That is how everything else in your life behaves. Throw a ball forwards on a moving train, and the ball does train speed plus throw speed every single time, without exception. That is not what happens here. The person outside measures the light at c, and so do you, and so does someone flying towards you at 90% of light speed. Same flash, 3 observers in wildly different states of motion, one identical number, which should be impossible. Speed is distance divided by time. If we all agree on the answer while disagreeing about how fast we are moving, then one of the 2 ingredients has to give. Our distances and our durations cannot be the same as each other. Einstein ran into this when he was 16. He imagined chasing a light beam, riding alongside it, and asked what he would see. If he could catch up, the light should be sitting there beside him, frozen. A standing wave of electricity and magnetism, hanging in space, going nowhere. Maxwell's equations have no such solution. The entire mechanism, the thing where a changing electric field creates a magnetic field and a changing magnetic field creates an electric field, only functions while the wave is moving. Stop it, and it stops existing. So a 16-year-old had a choice. Either Maxwell is wrong, or nothing can ever catch up to light. He took the second one, which turned out to be one of the better decisions in the history of thinking. But he still owed the world an answer to the question we started with. Why is it the same for everyone? One more clue before we get there. And this one is a proper piece of school betrayal that almost nobody mentions. We do not measure the speed of light anymore. We stopped in 1983. Since then, it has had an exact value by definition. 299,792,458 meters per second. Not approximately. Exactly. There is no uncertainty attached to it, and there never will be again, because nobody is measuring it. What we did was turn the whole thing around. We define the second using a cesium atom. Then we define the meter as the distance light travels in 1/299,792,458 of a second. So when a modern lab measures the speed of light very carefully, they are not learning anything about light. They are calibrating their ruler. Think about what we quietly admitted when we did that. We stopped treating c as a fact to go and find, and started using it as a conversion factor between 2 units, the way you would convert miles into kilometers. We just never said it out loud. So here is the profile of the thing we are chasing. It falls out of the properties of empty space. Every observer agrees on it regardless of how they move. And we now use it to turn seconds into meters. Speeders do not behave like that. Geometric constants do. So let us go and find out what it is the geometry of. I want to start by getting rid of the number, because the number is a red herring, 300,000 kilometers per second. Why so enormous? Why that particular value? The honest answer is because of the size of a human body. A second is roughly a heartbeat, the unit we invented for how long a moment feels. A meter is roughly a stride, the unit we invented for how far a body reaches. Both of those are facts about us. Neither is a fact about the universe. So when we express a cosmic conversion factor in heartbeats and strides, of course the number comes out absurd. It is not reporting that light is fast. It is reporting that our time unit is gigantic compared to our distance unit. Watch what happens when we fix that. Stop measuring distance in meters and measure it in light seconds instead. A light second is just however far light gets in 1 second. Now, how fast does light travel? 1 light second per second. The speed of light is 1. That is its actual value. Every one of those digits is an artifact of the fact that a human stride and a human heartbeat were invented separately. by people who had no idea they were measuring two directions of the same thing. Physicists do this constantly. It is called working in natural units. You set c to 1 and never write it again. It is the equivalent of noticing that your equations get simpler once you stop measuring width in inches and height in centimeters. And now the real statement becomes visible. The constancy of the speed of light was never a claim about how fast light goes. It says that there exists one universal exchange rate between distance and duration. 1 second of time corresponds to exactly this much space. Everywhere, for everyone, permanently, that is a statement about the arena. Your motion changes where you are inside the arena. It has no power over the arena itself, which is exactly why your motion cannot change the number. All right, now the picture. This is the part I would keep if I had to throw away everything else in this video, because once you have it, relativity stops being a list of strange results and becomes one shape you can rotate in your head. Forget physics for a minute. You are walking across a completely flat field, and you have exactly one speed, 5 kilometers an hour. You cannot go faster. You cannot go slower. The only thing you control is your direction. You start walking due north. After an hour, you are 5 kilometers north. All of your motion went into northness. Now turn 30 degrees to the right and keep going. Same speed. Nothing about you has changed. But after an hour, you are only about 4.3 kilometers further north, and you have picked up 2.5 kilometers of eastness. Did you slow down? Not at all. You are still doing 5. You re-aimed. Some of what used to be northward progress is now eastward progress. Nothing was lost. Something was traded. Now turn all the way to due east. Your northward progress is 0. Every scrap of your 5 kilometers an hour is going sideways. Hold on to that, because that is the whole of special relativity. Here is the substitution. North is time. East is space. And the fixed walking speed is c. Everything moves through space-time at that same fixed rate. When you sit perfectly still, you are traveling due north at full speed, and all of your motion is pointed through time. That is what sitting still is. It is aging as fast as it is possible to age. Get up and walk across the room and you turn your arrow slightly. A sliver of your motion through time gets re-aimed into motion through space, and your progress through time drops. Not by much. Walking speed compared to c is a rounding error on a rounding error. But it drops, and with a good enough clock, you can watch it happen. That is time dilation in full. Motion does not damage clocks, and nothing reaches out to squeeze time. You simply cannot spend the same arrow twice. Every bit you aim into space is a bit no longer aimed into time. Light is the extreme case. Light is due east. 100% of its motion goes through space, which leaves exactly 0 of it pointing through time. Hold that thought, because we are coming back to it, and it gets much stranger than it sounds. Now, I promised you his honesty, and this is where it is owed, because this picture is genuinely contested, and I would rather tell you that than let you repeat it in an argument and get taken apart. It comes from a physicist called Lewis Carroll Epstein in a lovely old book called Relativity Visualized, and he was completely upfront about its status. He called it a good myth. His phrase: a description that is not technical, and maybe not exact, but is not wrong either, and captures the truth of what is going on in a loose way. Go and read what professional relativists say about the phrase, as I did, and you will find real objections. The quantity involved is called the 4 velocity, and its length is fixed at c. But plenty of physicists will tell you that is a consequence of how the quantity is defined rather than a discovery about the world. Others point out that in space-time, nothing moves at all. Your entire life is already sitting there as one fixed line, and describing that line as a journey is a story we are importing. Those objections are fair. So let me hand you the rigorous version underneath the myth, because it is only one line, and it is just as beautiful. Take any object. Take how fast its own clock ticks compared to yours and square it. Take its speed as a fraction of c and square that. Add the two together and you get exactly 1. Always. For everything, that is Pythagoras. A right-angled triangle whose hypotenuse is always 1. And that is the entire mathematical content of the arrow picture. The arrow is a drawing of that identity, not a claim that something is shoving you through time at some velocity. Your clock rate and your speed are the two legs of a triangle whose hypotenuse never changes length. So when I say everything moves at the speed of light, what I mean precisely is that for every object in the universe, those two squares add to 1. That version is honest, and it also lets you check every single claim I make for the rest of this video. Right. Let us go and spend the arrow. Start with a clock that is sitting still. Its arrow points entirely through time, so it ticks at the maximum possible rate. There is no faster clock than one that is going nowhere, which is worth saying out loud, because most people have this backwards. Rest is the special case. Rest is the maximum. Put that clock on something fast and the arrow rotates. The time component shrinks and the clock slows. Because it is a rotation, the shrinkage follows a cosine, which is why the effect is invisible at ordinary speeds and brutal near c. At walking pace, you have turned the arrow by an angle no instrument on Earth could resolve. At 90% of c, the time component has dropped below half. At 99.9%, it is around 1/22nd. And this is not theory. It is a measured, load-bearing, industrial fact. Muons are particles created when cosmic rays hit the upper atmosphere, about 15 kilometers up. A muon sitting still survives roughly 2 microseconds before it decays. Even at light speed, 2 microseconds only buys you about 600 meters, so essentially none of them should ever reach the ground. And we should not be able to detect them at sea level at all. We detect them constantly. They are pouring through your body while you watch this. They are traveling at something like 99.9% of c, so their arrow is almost entirely aimed into space, and what remains pointing through time is tiny. Their internal clock is crawling, and the trip that should have killed them costs them almost nothing. If you want something less exotic, use your phone. GPS satellites orbit 20,000 kilometers up, moving at about 14,000 kilometers an hour. Because they are moving, special relativity slows their clocks by about 7 microseconds a day. Because they sit higher in Earth's gravity, general relativity speeds them up by about 45. Those do not cancel. The net is a gain of roughly 38 microseconds every day. 38 microseconds sounds like nothing at all, but GPS works by timing light signals, so a timing error becomes a distance error at the speed of light. Left uncorrected, your position would drift by about 10 kilometers a day, and here is the detail I love. They do not fix this in software afterwards. They fix it at the factory. Every GPS satellite launches with its atomic clock deliberately tuned to run slow, offset downward by about 4.5 parts in 10 billion, so that once it is up to speed and up to altitude, relativity pushes it onto the correct rate. There are engineers whose job is to build a clock that is wrong on purpose so that Einstein can correct it. That is the confidence level we are operating at. Which brings us to the question everyone asks next. And it is the right question. If I watch your clock run slow, what do you see when you look at mine? You see mine running slow. Both of us, simultaneously, each entitled to say the other one is the slow clock. And neither of us mistaken. That sounds like a flat contradiction, and it is the exact point where most people quietly give up on relativity. So we are not skipping it. It survives because comparing two clocks that are far apart requires you to decide what now means over there. And the hidden assumption in that sentence, the one nobody warns you about, is that now is something everybody shares. That there is a single universal slice of the present moment cutting across the whole universe. And we are all standing inside it. There is no such slice. When you tilt your arrow, you also tilt your idea of now. Two events that happen at the same moment for me are not simultaneous for you if you are moving relative to me. Neither of us has a broken clock. Now is a direction in space-time, and we are pointing slightly differently. So when I call your clock slow, I am measuring it against my slice of the present. When you call mine slow, you are measuring against yours. Two different cuts through the same block, two correct answers to two slightly different questions. That is the piece that took the world 20 years to swallow, and it converts time dilation from a paradox into bookkeeping, which finally lets us settle the twins, because I promised you the twins, and this is where they make sense. Two twins. One stays on Earth. The other flies out to a distant star at high speed, turns around, and comes home. The traveler comes back genuinely younger. Not appearing younger, not younger by some accounting trick. Fewer birthdays, less gray hair, a shorter life lived. The apparent paradox is obvious. If motion is relative, and each twin saw the other's clock running slow, why is the answer lopsided? Why does one of them actually win? Because the situation was never symmetric. One twin turned around. Staying on Earth is a single straight path through space-time. The traveler's path has a corner in it, and at that corner, when the ship swings around and heads home, the traveler's idea of now swings with it. The slice of the present they were using tips over and sweeps across years of the Earth twins' life. Only one of them experiences that. Only one of them changed direction. The symmetry breaks at the turn, and it breaks for the one doing the turning. And now the part that I think is the single most beautiful fact in this entire subject, which almost no explanation bothers to tell you, in ordinary geometry. A straight line is the shortest distance between 2 points. That is drilled into you at school. In space-time, it flips. The straight path between two events is the one that takes the most time. Ride that again. Sitting still is a straight line through space-time, and it is the route that racks up the maximum possible aging. Any detour, any bend, any acceleration, any deviation whatsoever, and you arrive having lived less. The twin who stayed home did not win because they were clever. They won because doing nothing is, geometrically, the longest possible way to get from one moment to the next. Every one of us is taking the lazy route through space-time and calling it a life, and it is the route that buys the most of it. All right, why can nothing go faster? The arrow settles it in one move. You cannot exceed C. For the same reason, you cannot turn more than 90 degrees away from north. The arrow has a fixed length. You may rotate it freely. You may not lengthen it. There is no direction more east than east, so the speed limit was never a wall that things slam into. Nothing is holding you back, and no barrier is being enforced. It is the radius of a circle. You can spend your arrow however you like. But there is only ever one arrow, which finally answers the question this whole video is named after. Why does light travel at exactly this speed? Because light has no mass. That is the entire reason. Anything with mass has to keep some of its arrow pointed through time. It has a rest frame, a place where it can sit still and simply age. Anything massless has no such option, because there is no frame anywhere in the universe in which a photon is at rest. So its arrow is forced all the way over to due east, and it travels at the one speed the geometry permits. Light obeys the speed limit. It does not set it. Light is simply the thing with nothing slowing it down. And now let us collect on what I asked you to hold earlier, because if light's arrow has zero time component, something remarkable follows. A photon does not age. Its clock does not run slowly, it does not run at all. And it goes further than that, because the same geometry that flattens its time also flattens its distances. Take a photon that left a galaxy 10 billion light-years away and ended its life in your eye. From where we sit, that photon crossed an unimaginable gulf and spent 10 billion years doing it. By its own accounting, No time passed and no distance was crossed. Emission and absorption were the same event. It left that galaxy and arrived in your eye in the same instant, with nothing in between. Now, the honest caveat, because this is one of those ideas that gets repeated badly. A photon does not have a valid point of view. There is no frame you can ride alongside it, which was exactly Einstein's problem at 16. So strictly speaking, a photon does not experience anything. What we can say rigorously is that this is a limit. Push yourself faster and faster, and your measured trip time shrinks, and the distance ahead of you contracts, and both of them head towards zero together. Light sits at the end of that road. It is a destination we can point at without being allowed to stand on it, which is a genuinely strange thought. Every photon that has ever reached us, from the sun, from a distant supernova, from the edge of the observable universe, made a journey that from its own side took no time and covered no ground. Okay, causality. Because the deepest reason for the speed limit has not arrived yet, and it has nothing to do with speed. Pick any event. A spark, a collision, this exact moment. Now ask which parts of the universe that event is able to influence. A signal leaves in every direction at the maximum rate, and after 1 second it has reached everything within 1 light second. After a year, everything within a light year. Draw that expanding sphere with time running upwards, and the shape it sweeps out is a cone. That cone is your future. Everything inside it is somewhere you could still send a message to, or reach, or affect. There is a matching cone pointing backwards into the past, holding every event that could have had any influence on you, and then there is everything else. The entire region outside both cones, which relativity calls elsewhere. Those events are not in your future and not in your past. You cannot affect them, they cannot affect you, and there is no shared answer to whether they are happening right now, because different observers slice that question differently, and all of them are correct. Right at this moment, something may be happening in the Andromeda galaxy. It is 2.5 million light-years away, so it sits deep in your elsewhere, not the future, not the past, and permanently beyond any conversation you could have with it. Most of the universe, at any given instant, is in your elsewhere. Those cones are not decoration drawn on top of spacetime. They are its structure, and they exist at every event, and their edges are set by the one conversion factor we have been chasing all video. So now the speed limit makes sense in a way it never did as a rule about fast objects. Exceeding c would mean stepping outside your own light cone. And because different observers slice now differently, a signal that leaves your cone arrives, for somebody, before it was sent. Not appears to. Arrives. The reply gets back before the question is asked, and worse, the order flips differently for different people. So there is no fact of the matter about which came first. The limit is protecting the order of events. Light is not what it is protecting, and that is why gravity travels at exactly the same speed. Gravity is not made of light, but gravity carries influence, and influence has to respect the shape of those cones, which is what those two neutron stars demonstrated for us in 2017. Two completely unrelated messengers, one built from photons and one from bending space, running the same race for 130 million years and crossing the line together. They were not measuring light that night. They were measuring the room. One more thing before we land. The most famous equation in the world, and a question almost nobody asks about it. E equals mc squared. Energy equals mass times the speed of light squared. Why is the speed of light in there at all? Look at what is standing on either side of that equals sign. Mass on the right, energy on the left. Neither of them is light. Neither of them is even moving, because this is the rest energy, the energy something has while sitting perfectly still doing nothing whatsoever. So why does a fact about light show up in the accounts? It does not, and it never did. That C is doing the same job it has done all video. It is converting units, The logic follows from everything we have already built. Space and time turned out to be two directions of one thing, with c as the number that translates between them. Mass and energy are also two aspects of one thing, and the translation between them has to be assembled out of the space-time conversion, because that is the only conversion the geometry owns. Why squared? Because energy is not a length. Its units carry a distance squared and a time squared inside them. So converting mass into energy means applying the space-time conversion twice over, exactly like converting square meters into square feet. You do not multiply by the length conversion once. You multiply by it twice, because you are converting in two directions at the same time. And here is the punchline. Go back to natural units, where c is 1, where space and time are measured in the same currency the way they should have been from the beginning, E equals m. That is the equation. That is what it has been saying the whole time. Energy is mass. Not related to mass by a big number, not convertible into mass under special circumstances. The same quantity, seen from two angles. The only reason a c squared ever gets written down is that human beings measure the two in different units. The most famous equation in physics carries a speed of light because we never got around to fixing our rulers. So let us go back to the sentence we started with. Nothing travels faster than the speed of light. Here is what it actually says, now that we have taken it to pieces. There is a fixed exchange rate between space and time built into the structure of the universe, indifferent to who is looking and how fast they are moving. Everything that exists carries the same fixed arrow through space-time, and the only freedom any of us has is how to aim it. Point it into time and you age at full speed. Tip it into space, and you trade away some of your future for some distance. Nothing can be aimed further than all the way, which is where the speed limit comes from. And that limit turns out to be a fence around which events are permitted to influence which other events. And light? Light is the witness, not the hero. Light has no mass, so it has no choice, so it runs at exactly the rate the geometry allows, and by doing so, it traces out the shape of the room we all live in. We looked at the fastest thing we could see, named the universe's most fundamental constant after it, and spent 150 years slightly misunderstanding our own vocabulary. It is not the speed of light. It is the speed of cause and effect. And there is one loose thread here that I cannot leave alone. Everything we did today assumed the field was flat. All those arrows, all that clean Pythagoras, every straight line, the whole picture lives in flat spacetime. That is what the word special means in special relativity. Special as in special case. But remember those GPS satellites needing two corrections, 7 microseconds from motion, which we have now explained completely, and 45 microseconds from altitude, which we have not touched. Because mass bends the field. The flat sheet we have been walking our arrows across is not flat at all. It sags, and when it sags, the arrows carry on doing exactly what we said they do. They just do it across a curved surface, and what we call gravity is what that curvature feels like from the inside. That is the next one, and if you want it, subscribe, because that is where this goes. Maxwell handed us the number. Einstein worked out what it meant. Next time, we find out what happens when the room itself starts to bend.